a very good evening, or good morning, or good whatever in the world. All right. So again, today is our what they call airport presentation for the month of April, 28th of April, 2024. So every end of the month, the Astronomical Society of Penang will present airport presentation. So today's presentation we are having a new format. So before that, I would like to thank our what they call Society of Penang member Michael Chu, who hosts this session. And of course, the picture was selected by our member Mr. Lai, who is now studying in Beijing. All right. So my name is Dr. Chong from the Astronomical Society of Penang, and together with me presenting are Dr. John Su Yu Han. All right.
Hi.
Who is an astronomer among all of us here, and our Miss Chiu Boon Wei, one and only Miss Chiu Boon Wei. Okay. So what I call, I was pass over to John. John, you can start your presentation.
Okay. Okay. Can you see my screen?
Yes, we can see our screen.
All right. So, good evening, everyone. I'm Dr. John Su, and I'm glad to be back to help out with the APOD. So it's been now. I think the last time I shared was probably 1 or 2 years ago. And
Yes.
Thank you, Dr. Chong, for giving me this chance to share this time round. So today I'm going to share about 5 images that we have. And the first one, of course, is the APOD picture for today, right, on 28th of uh, April 2024. So the picture that you're seeing here is a very beautiful image. If you don't know astronomy,
So
it
nice.
will look like, like an eye, right? It looks like as if someone's eye, or it was an artistic picture of an eye. But if you look very closely, it is actually an image of a nebula, right? This is a very, very famous nebula. It is called the Ring Nebula, okay, also called M57. So the Ring Nebula is about 2,500 light years away. It is in the direction of Lyra, the constellation Lyra. Lyra is actually like a hub, right? So it looks like a hub. So the name, as you can see, is called the Ring Nebula because it kind of looks like a ring. So if I zoom in again, basically, if you can see it, right, there is like many, many layers of the ring. Right? You can see that there is a main circular layer in the center. And then as it goes further and further outside, you can see that there's a lot of red color over here, right? So this is a very interesting picture, right? Because this picture is actually a composite picture of 3 different telescopes, right? So the astrophotographer Robert Gendler, he took an image from the Hubble telescope, from the Large Binocular Telescope, and also Subaru telescope. So he took 3 different telescopes images, and he actually made a composite picture to give us this really, really wonderful picture over here. So you see that at the center of the rings, right, the center rings is about 1 light year across. That means if for a photon to travel from one end to the other end, it takes about 1 year to travel. So in astronomy terms, 1 light year is actually not a lot, but then again, you can think about it, right? So it's like light traveling from one end to the other end. So in one way, it's actually not very, very far, right? That light can travel within there. And as you can see that there's a lot of gas being sent out. So this picture, of course, a lot of images, they have different colors, but the particularly interesting about this thing is the red color that they purposely set it to the color of hydrogen. So hydrogen, we know that is the most abundant element in the universe, and red basically is because we have the hydrogen alpha line, right? So this is one way that we can see the best view of ionized hydrogen. So the red shows you the distribution of the hydrogen alpha. Okay, so how did this ring nebula form? Well, basically, it is classified as a planetary nebula. So in case you're wondering, there are actually about many types of nebula. Okay, there's the reflection nebula, there's a dark nebula, there's emission nebula. So all these are like just gases, either they're illuminating themselves or they are being reflected, or they are just dust in the foreground. But planetary nebula is quite interesting because it is a little bit different from the other nebula that we mentioned before. Planetary nebula, despite the name planetary, has nothing to do with planets. It is actually an end state for a nebula. So, for example, when a star is going to turn into a white dwarf and it's going to die, then it's going to produce the remains of a nebula. So that's why it's actually a sort of remnant, and we'll see one more type of remnant later, right? So a very interesting thing before I go to the next picture is that the ring nebula actually really looks like a ring, right? Despite the fact that you may think that it's actually just a shell, a spherical shell with something in the center explode. So what happens is that people found out that actually it's more of like a donut shape. So it's like you have like a donut, in between you have something, and then you are actually looking through the top of the donut. So that's the reason why we can see a very blue center, and red, how do you say it, the exterior. Okay, so let's go to the next picture. This is speaking of rings. As you can see, there seems to be rings around here, right? This is actually a volcano, and then you see like really nice, interesting rings. The last time I saw these rings was I remember the cartoon Peter Pan, like it's a 1940s Peter Pan story. And then you see the red Indians jumping around, then they produce like the smoke rings to try to talk to each other. So you see smoke rings in real life other than in cartoons, right? And of course, the main actor over here is the moon, right? You can see the crescent moon. So this picture is taken by Dario Gianobo. So sorry if I mispronounced that. It is actually taken in the background of Mount Etna. So Mount Etna is located in Sicily in Italy. So it is called a stratovolcano. So a stratovolcano is like a volcano that is actually sedimented by many, many layers, right? So as compared to the normal volcano, this volcano is like formed because there are many, many layers of it. So basically these smoke rings that you see over here, right? These tiny smoke rings, they're actually called vortex rings, right? So how are they formed? Well, because this is not a physics lecture, right? But generally you expect that there must be some physical, thing going on. And generally, it's because of the gas that is inside the rings moving faster. So they push the ash surrounding them, right? They kind of push them open. So it means that these rings are actually not very common. They are very rare. They have to be in a certain right geometry, the speed of the atmosphere and everything to occur so that you can actually see these rings. So this picture, I would say, is rather interesting because it highlights that, in the background, even though you see an astronomical object, we didn't really talk about the moon here, but as you can see, sometimes you can put composite images in one single image. You can see multiple interesting things in there. Okay, so this was the APOD of 22nd of April. So let's go on to the next one. Okay, this one is interesting. Okay, this is also a composite image of a lot of things going around. Okay, so some of you may know that recently we just had a solar eclipse, right? So here you see that there is a picture of a solar eclipse that was taken in the background, okay, with respect to many things that are ongoing. Okay, first of all, the image of Mercury is visible, okay. It's very, very, very faint here, but of course you can see Venus much more clearer. But what is more interesting is that there are actually two comets that are being visible over here, right? So it's like I say buy one free four, right? So you take one image of the solar eclipse and then you see all five images all together. Okay, maybe Mercury, Venus is very common. So let's talk about the comets today. So these two special comets that just so happen to be in the background of the sun, okay, is their names are Comet 12P, also known as the Pons-Brooks comet, so name of the people who discovered them, and also the comet Soho 5008. So Soho 5008 basically is the name for the probe that actually observes this comet. Okay, so as you can see, we can also see the corona. That means the surrounding of the of the sun. So maybe let's go back a bit and take a good look at it. So as you can see, you can see the corona extends very, very large, very, very far away from the radius of the sun, right? So yeah, it's only you, or rather, you need something to block the center, right, in order to actually see the majestic corona. The corona can go up to very, very high temperatures over there. Okay, so I think let's go to the next image, and this image over here looks similar to the nebulae, right? It looks very beautiful. As you can see, there's a lot of colors. Some of you may think that it looks like an AI generated image, or maybe some may think that it is possibly like some blood veins. You look into it, but no, this is a supernova remnant. Okay, or we call it SNR. So similar to just now what we saw earlier on, the ring nebula, SNR, supernova remnant, is also a remnant of something that happened. Okay, and in this case, this is much more greater than the previous one. So this is due to a explosion, a very massive explosion of a star. So we know that the end points of stars can be very different, depending on the size of the star. So if you have a star that is so small that it probably wouldn't explode, then it would just basically become a what we call as a brown dwarf, right? It would just die, and then it will not. It will be a failed star. It's so small that it cannot even burn. It cannot even proceed to the next step. What we saw earlier on is like a sun-like star, right? Possibly that when it grows old, when it finishes all its helium and hydrogen, then it will leave a white dwarf behind, okay, at the center, and then there'll be a planetary nebula around it, which is the thing that we saw earlier on in the white in the previous image. And then if you have even larger stars, what happens is that you actually produce an explosion. And an explosion, of course, is called a supernova, and the remainder of the explosion can be one of two things, right? Either number one, it is a neutron star, which is a star that is fully packed by the neutron degeneracy. It's like really like really a very fast spinning neutron star, or it can also be a black hole, which I think many people are more familiar of. Okay, coming back to Vela supernova remnant, well, basically it's a star in the constellation of Vela. It exploded about 11,000 years ago. So 11,000 years ago is about the beginning of the recorded history, right? So usually we can date back up to about 6,000 BC, 7,000, 8,000. So it's probably almost the earliest recorded history that we can have of astronomy or anything else. Okay, so that means this is a very, very old star. So and it is probably so dim that you can't see where it is in this picture. So it forms a supernova. So of course, supernova basically is just a remnant, as I mentioned earlier. So basically, what you see here is what we call as the interstellar medium. It is the medium between the stars, and then you see that they are just filling up the space, right? So what do supernova remnant do? Well, basically, the reason why they look so pretty is because the progenitor or whatever is in the center, right, is producing so much heat, it radiates and it heats up the gases, of the entire shield or the entire dust and gas that's around it. So the supernova remnant, of course, this interstellar medium will continue to become the next so-called like the raw ingredients material for the next star, right? So if you have enough of these gases, or they actually knock into one another, then they will actually condense and they will produce new stars. Okay, so there's actually a central pulsar. A pulsar is just a name for a rotating neutron star. I would say generally most neutron stars probably should be rotating. They should be spinning really, really quickly. So it spins at a period of like 0.1 seconds, very, very quickly over here. Okay, so my last picture for today that I'm going to present is this over here. So we are looking at a galaxy, and you see that there's a box over there that boxes out something in the center over here. So as some of you may know, the Hubble telescope was sent to space in 1990, was born in 1990, right? So Hubble Space Telescope has always some significance for me. And as you can see, it's always taken in like color. And then you zoom in to this box over here, and this is taken by the James Webb Telescope. So the James Webb Telescope is something very, very recent, right? So it is has a much higher resolution than the Hubble Telescope. So this image here is to signify, to tell you that, we can actually zoom in to see some really, really much better stuff in there. So this is the Cigar galaxy, because it's the shape of a cigar. And we see that there's a lot of interesting things happening here. So you see that there's a lot of red gas and red dust at the top and the bottom, right? There's something about galaxies that you should know, that they usually have to spin. And when they spin, there is some symmetry in it, right? So that it means when it spins, that means that there is a direction where you expect to see a disk, and there'll be a direction, that the things will be spewing out, top and bottom. So that's what the red stuff that you see are, right? So it's called a starburst galaxy because there's a lot of star formation going on. There's red glowing gas, the dust is casted out from the center, from the hot plasma. And the Cigar galaxy is also called M82. So some people say that the reason why M82 is being so explosive possibly is affected by its neighbor called M81. So the M is basically the Messier object. So the Messier catalog, M81 and M82 happens to be discovered at the same time because they're neighbors. But in that catalog, they don't follow any like special order in terms of location lah. But in this case, M82 and 82 were discovered together. And basically what people say that this is like what we call a galactic super wind, right? They are like emerging particles, winds that just send out far away. So these are really, really interesting things. And people, I would say the scientists are still trying to explore what are they made of, right? Another final note is that, of course, HST is observed in the Hubble Space Telescope is observed in actual visible light. So if your eyes are going to see exactly what it looks like over here. Whereas on the right-hand side, this is actually false colors. They take infrared light, they give them colors. So actually the red that you see over here do not exactly correspond to the red that you see over here. Okay, but at least it is a way that you can actually see through the dust and gas so that you can see the stars, the formation of the stars and the back. Yeah. Okay, so that is 5 images that I want to share for today. Okay, so I'll pass the time back to Dr. Chong.
Thank you, Dr. John Su. I'll share my screen. Okay, I'll be presenting 2 pictures here. So it is April the 13th, palm tree partial eclipse. That's nice. And this has happened in Malaysia many times. The partial solar eclipse even happened before what they call total solar eclipse. And you can see this. So basically, it's taken by Miss Lori Harpel, right? And she was actually in Florida, right? In Florida, in the southern part of America, Clearwater, Florida, and she on the floor, on the ground, she took this. So good. For them, they call it's a palm tree. For us, it's a coconut tree lah. So basically, in Florida, the totality part doesn't pass over there, so only the partial phase. But it's interesting because we know that Florida is the south of the part, the central part. The central part actually pass over the city of Dallas in Texas, and so on. All right. So this is on the south. So that's why you find that, and this part, when the what you call the partial solar is occurring, you see the partially eclipsed sun, all the curve is pointing up because this is south of the total part. But let's say you are north of the totally part. Let's say you are in Chicago, then you find that the crescent will be pointing downwards. But this is because you are in the south. That's why the crescents are pointing outward. Very nice. So all these crescent, and we have seen it many times in USM and Penang. So what happened is I'll tell our members to lie down on the ground and take a picture of you lying down with the crescent. It's possible, all right? So this is just a kind of a pinhole camera effect. What is a pinhole camera? Because remember, up in the palm tree there are a lot of gaps in between the leaves of the tree. So basically, under normal condition, when there's no solar eclipse, this gap will be a circle, a bright circle, that the light from the sun passes through a gap in the leaf and will cause a circle. But you may say, but if the gap is square, no, if the gap is square, but if the gap is very high up in the tree, very high up, coconut tree height, then whatever the size shape of the gap you have, but what falls on the ground must be a circle. If the sun is circle, but now the sun is a crescent sun, so you see a lot of crescent sun. Very nice, right? So this is our palm tree partial solar eclipse taken by Miss Lori Harpel from Florida, right? Which occurred recently on the 8th of April. Okay, the next one would be the 8th of April. This is really incredible. Now this is taken by our 2 amateur astronomers, all right, Shen Yu Li and Shen Ying, all right. So this is the changing iron tail of comet 12P Browns-Brooks, the similar one that Dr. Johnson was presenting, but this is taken by these 2 amateur astronomers, and basically they took it from a whole series of what they call days in March, right? From March the 6th to the 14th, over 8 days, and this is over that 8 days they took it. So basically you can see, that here the comet is further away from the sun, so the coma is smaller and the tail is shorter. And now here, as it goes closer to the sun, the tail will be longer. All right, and remember, a coma usually have a few what they call shapes. One is you have a point in the center where you don't see the nucleus, the only part of it which is solid, and then you have the coma, all right? The coma is very big, all right? Can be a few 100,000 kilometers in diameter, and then you have possibly two tails. But here I only can see one tail, which is the ion tail, the straight tail. The ion tail is caused by the sun's solar particles, which is by the ions, charged nuclei of the nucleus, and also the electrons hitting the particles in the nucleus and creating this tail. This is the ion tail. But what is interesting is, you look, there's a changes in the shape of the ion tail. So, for example, we know that basically the sun has a strong magnetic field on the surface of the sun. But as you go further away from the sun, this is the orbit of Mercury, there's still some magnetic field of the sun at the orbit of Mercury, even at the Earth. Even right unto our Neptune, the furthest planet from the sun, there's still a very weak magnetic field of the sun, right? So basically, when you have this ion tail, will cross the magnetic environment of the sun, and if you have a sudden change in the magnetic field, it's called a disconnection event. So in other words, the tail can break off, or like this. So you can see some disconnection event. So a lot of details here in the tail. So by the way, this doesn't mean that you have so many comets at the same time. So basically, it's taken over a period of 8 days, and these two gentlemen will align them as if they're all in the same part of the sky. Actually, they are different parts of the sky over the 8 days. And remember, even if you go to the coma, you may say that it's actually very choking. No, it's actually a very good vacuum. The space that is only that you are just above the nucleus of the comet, that the particles that are spewing up is like the density of the particles they have. But a bit further out, it's like a vacuum. So basically, everything here is like a vacuum. Even like in the nebula, you see, or even like in the Vera supernova remnant, it's actually a good vacuum, right? But it's not full of material. Looks like a full of material, but it's actually like a vacuum. So this is our beautiful what you call changing ion tail or comet Pond's book. Okay, this is ion tail, but you don't see much change in the coma of the comet. And then the coma, why is it green? We know, because the solid part of the comet, the nucleus part, is made of diatomic carbon, C2, and diatomic carbon, when the what we call sun's UV light falls on it, you will create the diatomic carbon to have fluorescence, and it will usually give a series of spectral lines in the green part of the color spectrum. That's why it's green, diatomic carbon. All right, so very nice. And then you see behind here a lot of stars behind here. Okay, so I will pass over to our Boon Wei.
Hi, thank you, Dr. Chong. Thank you.
Yeah.
Okay, so let me share my screen first. Okay. Entire screen. Okay, so here is my first picture to present. Yep. Have you seen the
Yes.
image? Yes. Okay.
Nice.
Yes. Yeah. So this is the first APOD I would like to present today. So this is the APOD on 12th of April. So the caption is the totality here. Yeah. So okay. So as the caption, right, this is a total solar eclipse that we all know that happened on the 8th of April, the solar eclipse. So this picture was taken at Durango, Mexico. So for the caption, total is actually means the total solar eclipse, that the apparent diameter of the moon is large enough to cover the sun photosphere, and the totality is actually the maximum phase of the total solar eclipse. Yeah, so this is the total solar eclipse here, and this series of amazing picture was taken by Daniel Corona. So in this series of image, it has the moon's it capture the moon age from the beginning through the end of the totality, and also you can see the Bali's beats. So what is the Bali's beat? It means that the very short moment, it's actually a very short moment that we can actually see during the total solar eclipse as the shimmering effect. Also when the moon is totally, I mean, like when the moon partially covers the sun, and then because of the lunar surface has an uneven terrace, so there will be like the sunlight filters through the gaps in between the moon mountains, is create something like the bit light spot on the lights along the moon edge. So it looks like a string of pearls encircling the moon, the sun during the eclipse. Yep. So also enlarged into the east, the picture, you can still see also the prominence is loading. Yeah. Right. Maybe I just enlarge it. You can still see the pinky prominence of the plasma, like arching along the active sun. So yeah, nowadays the sun, I think, is very active, so hot nowadays. Yep. Okay, so the totality is actually last for 3 minutes and 46 seconds in Durango. Yep. Okay, so this is the image. So I'm go to the next APOD. Okay.
One comment will allow me. This will make a very good engagement photo for a girl. So photographer
Yeah,
is
the
right?
ring.
Take this picture. Give to the girl.
All right, so oops. Okay, so let me go to my next picture. Is actually on the 5th of April.
Ooh.
This is the solar coronas. So I think just now Dr. Johnson also did explain on a bit of the total on the solar corona. So this is another like fantastic picture taken on the sun, and also happened during the eclipse, but probably not this year. Is what taken on the 2017 and the 2023. Yeah. So this is the solar corona taken by Peter Watt, and it has actually the solar corona was taken in, the top there is 2023, and the bottom there is 2017. Is eclipse seen from the Jackson Hole warming, and top there is actually at the Exmouth, Western Australia. So we know that the last year is actually a solar maximum year. So the sun got 11-year activity cycle. So like the variation of the level of solar activity is happen on the surface over time. Is like have like the phenomenon got a sunspot, solar spheres, and yeah, this is at the maximum year. So you can see there's a lot of the how to say, the corona, I mean, yeah, the spikes and the solar flares, sunspot, everything on the solar eclipse. And then 2017 is the minimum year, so it's like can see the less active there. Yep. So so this solar corona is actually only can visible by eyes while standing in the shadow of the moon. Meaning only the solar eclipse happen, then we can use I mean to visible to the eyes. But of course with some protective spec, so that can see this. Yep. Okay, so I will go to the next report. Okay, so the next report is on the 3rd of April. Unusual nebula PA30. So it looks like fireworks on the sky. Yeah, so so this is the nebula PA30 that taken by the NASA, ESA, SAF, and NSF, and processed by many astrophysics from the University of Manitoba. Yeah. So, and also there's a professor Fesson from the University Dartmouth. So yeah, it looks like a beautiful firework, and it's actually located somehow is some its location is seems to be the supernova happened in a year 1181, that actually also in between of the August 4th of August to 6th of August by the Chinese and the Japanese astronomers. So our astronomers also named it as SN1181. So in the model or the study on this nebula, it suggests that it is the remnant of a very rare class of the supernova, like known as a subluminous type 1AX supernova. So yeah, we have several type of supernova, and you can see at here the blue dot in the center. They actually hypothesis that it could be a zombie star. So it means then there is a remnant of the white dwarf that somehow like survived when this supernova explosion. So also this nebula also it quite different from the normal type of the supernova. It could be a merger of two white dwarf stars spiral together, yeah, then explode. Yes. So this feature image is actually combine the image and the data obtained with the infrared wise visible, and then also the X-ray Chandra telescope. So we can still like the astronomer and the astrophysicists are still analyzing the data, and then maybe the more observation and also the analysis will help us to understand more on this nebula. Yep. All right. So I go for my next picture. Okay, so my next picture is on April Fool, the 1st of April, but it's not April Fool. This is our galaxy central black hole. Yeah. So let's discover our black hole, and this image is credits to the EHD collaboration. So what is happening to be the big black hole in our center of the galaxy? So you can imagine there is a swirling disk of the metal orbiting around the black hole, and now they confirm that the disk is magnetized. Yeah. So this is the close up of the Sagittarius A. Yeah, taken by the radio telescope around the world that participating in the event of Horizon Telescope collaboration. So we call it that EHD. So the superimposed image are actually these curved lines are like indicate the polarized light like emitting from the swirling and the magnetized gas. Yeah, that is being swallowed by the black hole. And this part you can see is appear dark because um even the very little light emitting gas visible between us and the black hole actually we cannot really see because the light is cannot escape from the black hole, right? Yeah. So okay, so for the I think we are still continue study, and then the EHD is still continue to monitor it. Hopefully we can get more clues about the gravity of the black hole and how the metals create this and the jets in the black hole. So that's all for me, and also that's all for tonight, April.
Thank you,
So
Boon Wei.
Yeah, I pass back to Dr. Zhong. Thank you.
So maybe we can check the Facebook and the YouTube. Any comments? Any questions from the people who are watching, listening? No comment, huh? So one thing is congratulations, John, Boon Wei, we did it slightly more than half an hour. Michael should be happy.
Yeah.
We made it. 34 minutes. Slightly exceeded by 4 minutes. Well done to all of us. All right. So I think maybe we keep it like what John said during our ASP community meeting, because people have now a shorter attention span. I think it will be just nice half an hour. Just nice half an hour. Okay. So thank you for everyone here with their forceful presentation. Interesting, Dr. John Su and Miss Chu Boon Wei, all right, and me, all right. So we hope in our coming presentation, more of the members can take part, including our Dr. Jiva, right? So any other further comments, John? Boon Wei?
No comments.
Yeah, okay. Right. Okay. Yes.
Oh.
Yeah. Bunwei, corona pictures of the total solar eclipse. How was it? The series of concentric rings one with the arching red prominence. How were it taken?
Oh, you mean
Show,
that one?
put up the picture again.
Yeah.
Beautiful picture.
Yeah. It's a very, very beautiful. I think they actually it composite it and then combine it into one picture. It's a composite image. Let me share back it.
Share that, share that.
Yep. Okay.
Wonderful.
Okay, so yes. So normally these are the composite image that they stack all the moment into one.
Yeah.
Yeah.
But usually what they do is they will take the central one as no doubt, but then as you go down now all the way, so they just displace it downward a bit more, and then so many minutes later, maybe I don't know, 5 minutes later, so many seconds later, displace it some more to the lower right, and before the total phase is on the top part, it was before coming in. Every so many minutes or second they take and they purposely displace it in space. But in time, it's all in time. It should be all in the central figure, but they displays it as if it's a kind of like a series of images. But it's not true. It's all done in the center. What's happening is only in the center, but they displace it. They displace it. Okay,
Mm.
very nice effect. Yeah.
I just want to add a bit about how to actually observe the corona. So actually, the solar eclipse is not the only way that we can observe the corona. Okay, there's this thing called the corona graph. It is basically it's like just like a camera, but except that at the center of the camera, you actually create like a cone shape, something to block the light at the center, right? So you have to adjust this very well. These are equipment that are built into wherever like the solar observatory is. And then you look at the sun, then you can actually block out the center light and therefore look at the corona.
Yes, yes.
So it's possible during non-eclipse time, but it will not be as clear as the eclipse time, because when you have a natural something to really block it, you can see much better.
It was a great invention by the French astronomer who made it. Yeah, yeah. Corona graph, solar corona graph. Yeah.
Mm. Thank you, Dr. Jansu, for the add-on.
Any other comment, Michael? Question? Right, huh? Yeah. So again, thanks to Dr. Johnsu and our Miss Chu Bunwei. Yeah. Right? Yeah. Thank you. Thank you,
Thank
Michael,
you.
for watching.
Bye.